Hi everyone, today let's look at how we can find the x and the y intercepts and then use them to sketch a parabola. Finding the x and the y intercepts involves looking at both the expanded and the standard form of our quadratic equations. The constant at the end of the standard form is the y-intercept. So in the example given, the -5 would be your y-intercept. The y-intercept would be written as a coordered pair of 0, -5. The factored form tells us the x-intercepts. We just need to use the opposite values of what's inside the brackets. So we would have a first 0, or x-intercept, of -5, 0, and a second x-intercept of 1, 0. Let's use these ideas to try to sketch the parabola. We've been given factored form in our first example, so y equals x minus 3 is in the first set of brackets and x plus 3 is in the second set of brackets. To find the x-intercepts, we'll take the opposite values from inside of these brackets. So our first x-intercept will be 3, 0, and our second will be -2, 0. We can plot these 2 points on our grid. So we'll go over 3 and up 0 and plot a point, and we'll go -2 and up 0 and plot a point. Now we'll need to convert our factored form into standard form in order to find the y-intercept. Let's use the chart method. On the left side, we'll put x and -3 for what's inside the first set of brackets, and across the top, we'll put x plus 2 for what's in the second set of brackets. X times x will give us x squared. X times +2 will give us +2x. -3 times x will give us -3x. And -3 times +2 will give us -6. We can collect the like terms to have y equals x squared minus 1x minus 6. The -6 is our y-intercept, so our ordered pair will be 0, -6. We'll plot this point along the y-axis. At this point, we have 3 important points along our parabola. In order to find a fourth, we can create the line of symmetry, or the axis of symmetry. We know that the axis of symmetry needs to occur halfway between the zeros. So halfway between 3 and -2, remember that to find the axis of symmetry, we can add the 2 zeros, the 3 and the -2, and divide that by 2. This will give us 1 divided by 2, or 0.5. So we can put our axis of symmetry at x equals 0.5. We can use this axis of symmetry to reflect the y-intercept, and that will give us our fourth point along our parabola. We can use these 4 points to sketch the parabola. This isn't exactly an accurate parabola sketch because we're not exactly sure at this point what the vertex would be. We are guessing at its location slightly below the y-intercept and the reflected point in the axis of symmetry. In our first example, we were given the factored form and needed to find the standard form. In our second example, the opposite is true. We're given the standard or expanded form of y equals x squared plus 7x plus 10. This tells us that we will have a y-intercept of 0, 10, because we know that the 10 at the end of the standard form represents the y-intercept. In order to find the zeros, or the x-intercepts, we're going to need to factor our equation. We know that we'll need 2 factors that will add to give us the middle coefficient of 7, but multiply to give us the final term of 10. 2 and 5 will work. 2 plus 5 will give us 7, and 2 times 5 will give us 10. So our factored form will be y equals x plus 2 in the first set of brackets and x plus 5 in the second set of brackets. We know that to find our x-intercepts, we simply take the opposite values from inside of the brackets for the x-intercepts. So we will have -2, 0 and -5, 0. We can plot these 3 points. -2, 0 is along the x-axis, Negative 5, 0 is also along the x-axis because those are the x-intercepts. Our y-intercept of 0, 10 can be plotted as well. From here, we can find the axis of symmetry. Once again, we find the axis of symmetry by looking halfway between our zeros. We can do this mathematically by adding the two zero values and then dividing by 2. So negative 2 plus negative 5 is going to give us negative 7. And when we divide that by 2, we will get negative 3.5. This means that our axis of symmetry can be placed at negative 3.5. We can use the axis of symmetry to reflect the y-intercept and plot a fourth point for our parabola. We could sketch the parabola roughly at this point through the 4 points that we have plotted. If we want to make our parabola sketch be more accurate, we have some choices. We've already found the axis of symmetry halfway between the x-intercepts. We've reflected the y-intercept using the axis of symmetry to find a fourth point on our parabola. We might go even further by finding the vertex. To do this, we know that the vertex will fall along the axis of symmetry, so it will have an x-coordinate of negative 3.5. We can substitute this value into our standard or our factored form equation to help us find the y-coordinate of the vertex. Let's use the standard form. We'll substitute negative 3.5 for every occurrence of x within our equation. This will lead us to negative 3.5 needing to be squared, which will be 12.25. 7 multiplied by negative 3.5 will give us negative 24.5. To this we'll add 10. As we simplify this, we'll have y equals negative 2.25. This is the y-coordinate of our vertex. This means that our vertex is negative 3.5, negative 2.5. We can plot this on our graph and then adjust the curve of our parabola to go through this vertex. An alternative to using algebra to find the y-coordinate of the vertex would be to use Desmos in order to check your sketch and to make it more precise by looking at the key points along the graph. To do this, you could enter either the standard form or the factored form into Desmos and check out the key features of the resulting graph.